All right, so today we're going to be hitting long and synthetic division. All right, so these are not always people's favorite thing to do, but here we go. All right. Okay. And yes, unfortunately, we need to use both. Okay, we need to use both. Alright, we need to use both. So, really, I guess you don't need to use synthetic division, but I mean, it'll be helpful, right? Because it's like a little bit faster than that long division is. So, alright. Before we do that, though, let's refresh our memories about the division algorithm. So we'll take the number 1,793 and we're going to divide that by 4. Alright? So sometimes this is what we might mean and make us do non-calculator sections where we have to like divide, you know, numbers that don't necessarily divide evenly. Right? So you have to know how to divide these things. So, okay, the first thing is we have to set it up correctly in the division like algorithm, right? So when you use division, right, normally we use this little symbol when we do long division. Okay? And what number goes in this box here, in this case? What goes in here? What's that? Yeah, the 1,793. The thing that is being divided. The thing that is being divided goes in there. And the thing that you divide by, we're dividing by the 4, that goes on the outside, right? So, like that, okay? And believe it or not, right, when this may be really simple and basic, right, and you're like, oh, Mr. Webb, this is like ridiculous. But when it comes to polynomials, it gets confusing, right? And people are like, whoa, which goes where and stuff. Or at least it gives students pause. So anyway, here we go. Okay, so now, to do the division algorithm here, or one way to kind of think about doing this long division algorithm, right, the kind of the rule that we use to do long division here, we start by taking our number here, the 4, right? It's our lead term. There's nothing behind it. There's no other numbers. It's just 4. And we look and ask ourselves, okay, what times 4 gives us 1? In that case, it's like, well, there's no real nice numbers, right, that we can multiply by 4 to give us 1. And so we'll kind of put like, we can't really use that. But then we'll move back to the 1 and the 7. We'll call that 17, right? And we'll say, okay, what times 4 can get us 17, or at least close to 17, right? And so what is it that we multiply by 4 to get close to 17? 4, right? 16 is going to get us there, so we'll multiply by 4. Okay? Because 16 is the closest we can get, so we'll say 4. Okay? And so we do that. We do 4 times 4, that gives us a 16, and they're going to subtract. Okay. Multiplication as an operation is really just repeated addition, right? When you first learned about multiplication, you probably learned about, like 3 plus 3 plus 3 is 9. But that's 3 3s. 3 times 3 is 9 also, right? Division is like repeated subtraction, all right? We just subtract and subtract and subtract. So you subtract those, you get a 1. All right? And then sometimes you like guess wrong and you have to like check. It's like, ooh, can I pull enough 4 out here? But no, we can't pull any more 4s out because it's just a 1 there. So we'll drop down that 9 there. All right, to make it 19. And so we ask ourselves the same question. What times 4 can get us close to 19? 4, that's right. Okay, so 4 times 4 is 16. So we subtract, and we get 3. Hey, you guys are going to talk the whole... Matt, can you come back to your seat, actually, please? Okay. Thank you. You can go back there later when you're doing the classroom homework. No, it'll be fine, I promise. I know he's probably lonely. There's some Danny back there. Okay. All right. Thank you, Matt. So we got 3 now. Again, 3 can't divide 3 anymore because there's no more 4s in 3. So we'll drop the 3 down. Okay, we get 33. All right. And so now what times 4 can get us close to 33? 8. Okay, so 8 times 4 is 32. Yeah, very good. So minus that, we get 1. And we've run out of numbers. Right? And so this one we call the what? The remainder. That's right. So remainder 1. Okay, so you can write it that way. Remainder 1. Or we can say 448 plus 1/4, right? That's another way to do it too, because we still have to divide that remainder of 1 by the 4, so it's kind of left over to divide by 4 still, so it's 448 plus 1/4, or you could say, 448.25 if you wanted to. That's fine too, right? Because that's the same idea. You're adding that 1/4 onto the 448, so something like that, okay? If you wanted to continue this to actually get the decimal, right? I don't know if you guys remember this, but you can put like a decimal point at this point, put a 0 in there and drop the 0 down, and then do 10, and then proceed from there, and it should stop. So you also put a decimal point right here, and then be like, oh, okay, 4 goes in there twice, 2 times 4 is 8, and then 2, and then you put another 0 in, drop it down, you get down to 20, and then 5 times the 4 gives you the 20, and so we finally get done there. So that's how you can do the decimals too, if you ever were like, whoa, how do you get decimals? There it is, okay? You just put a decimal point when you run out of numbers, and you add some zeros on and keep dropping those zeros down. Eventually, you'll either see a repeat in the decimal, right, or you'll see it terminate at some point. Okay, either repetition or termination. Okay, so there it is. Mind blown, right? Long division. So were you guys ever taught this? Do they still teach this in Common Core and stuff like that? You guys have seen this before, right? Is this all familiar to you? Has anyone never seen this before? Okay. Because I know that Common Core, they were trying to get away from this kind of stuff. I don't know, and some teachers, liked it, some teachers didn't. So, anyway, let's now use long division. Okay. To simplify f of x equals 6x cubed minus 19x squared plus 16x minus 4, and we'll put that all over x minus 2. So now we're going to use long division on a polynomial. Now we're going to use long division on a polynomial. Okay? So, let's do that. Alright, so again, the thing we are dividing is the 6x cubed, and so that goes in the little box there. Okay. And then we'll put the x minus 2 right there out front. Okay. And so now we ask ourselves the same question we asked ourselves before when we were doing long division, okay? We want to think about, is there something, right, that we can multiply by x to get 6x cubed? And the answer is, yeah, we can, right? What can we multiply by x to get 6x cubed? 6x squared, right, okay? So the 6 times the 1 will get us a 6, and then the x squared times the x will get us x cubed. And so now we'll multiply 6x squared times the x, 6x cubed, 6x squared times the minus 2. Yes, we have to multiply to both things. 6x squared minus 2 minus 12x squared. Okay? And just like in long division, we need to subtract that quantity. So subtract, and I'm going to use parentheses here. Because it can also get tricky trying to keep track of all the signs and stuff like that too. All right. Now, I don't like subtracting quantities. I like to change it to addition to add opposite. If you feel comfortable with subtracting, especially subtracting negatives, do it. But I'm going to go ahead and go through this, and instead of changing to subtract, I'm going to make it plus, and make it just plus negative 6x cubed and a positive 12x squared. So I just find it much easier to add. Okay, but that's for me. My brain is simple. All right. So those cancel out. Negative 19 plus 12, negative 7x squared. Easy. And then you bring down that plus 16x. And we ask ourselves the same question we did before, right? So then what times x will get us this negative 7x squared? So what do we need to multiply x by to get negative 7x squared? Negative 7x. Very good. Yeah, so minus 7x up there. Okay. So then we get negative 7x squared, and then negative 7x times negative 2 is positive 14x. And again, we'll subtract the quantity. But again, because I'm simple. Instead of subtracting, we'll do plus the opposite. Add the opposites there. So the 7's cancel like they should. And then 16 plus negative 14, 2x. And then the last one will bring down the minus 4 there. And then what times x gives us 2x? 2. So 2 times x, 2x. 2 times minus 2, minus 4. Subtract the quantity. And so that's going to cancel, that's going to cancel. We're done there. We get 0. No remainder. Woohoo! Okay. So there it is, divided. Right there it is, divided. So what that means, right? What that means is that this polynomial up here, while you may look at that, or this, I guess, this rational function, this numerator, right, it factors. Now, you might look at it and say, well, it looks like we could factor it by grouping, and yes, we maybe could factor by grouping there. It looks like there's, at least 4 terms, and there's something we can maybe factor out here and factor out here, but I don't know if that would help necessarily. But we do know that this thing does factor to be x minus 2 times, and then what was left over here, the 6x squared minus 7x plus 2, right? If we took this polynomial, divided it out in x minus 2, and we're left with this, that means that these two things, they multiply to give us this, right? If we take this and divide by this, that means these two things must multiply back to give us this here. So we can kind of like use long division to help us factor something that otherwise maybe wouldn't be able to factor. Okay, just like that. So those two things are equal, and then of course, we can cancel those things out, and we'll say that that's equal to then just this. But I do need to put one little caveat in there, that x does not equal 2. Okay. Why do I need to put that little x not equal to 2 in there? Say what? Sorry again? Yes, in the original function, right, if I plug in a 2, this thing's undefined. But if I go to this supposedly equivalent form over here, I can plug 2 in and have no problem. So the equal sign, folks, is a very powerful sign, and it has a very specific meaning in math, right? It means these two things are exactly the same everywhere. Well, technically, these two things are not exactly the same everywhere, because here, this one's undefined at 2, this one is fine at 2. So that's why I put in that little caveat there, except the x not equal to 2. So these two things are precisely equal everywhere when x is not equal to 2. So we can still kind of use that idea of equality, just except at one point. Okay. All right. One little quick side note here too. If we had done something like this, where we had 6x cubed plus 16x minus 4, and we wanted to divide that by x minus 2. So just slightly changing the problem here. One thing I want to, just call this like a side note. We'll call these placeholders. Okay, you'll notice in here, unlike in the original problem, we had an x cubed term, an x squared term, an x term, and then just a constant. Here you'll see we jump from a cubed term down to just the x term, right, and then down to the constant. So we're missing that squared term. When you go to write that in your long division problem, okay, we need the placeholder for the squared term. So when you have that 6x cubed, you need to put in a plus 0x squared there as your placeholder. Likewise, if you're missing something here as well, then you want to put a placeholder in, but there's no placeholder in our divisor, I think is what that is called. Okay. So just watch that. That's a placeholder right there, okay? We're missing the x squared term, so we need to put in a 0 placeholder there for that. Okay, that's our placeholder. And that, if you put one in either the thing that you're dividing by or the thing that you're dividing. Okay, both of those need it. So, thank you. Very good. Okay, so any questions on any of that? Easy peasy. All right, let's try another one here, and then I'll have you guys try one. Okay. Well, maybe we'll see here. This next one's going to be a little tricky too. Alright. Let's divide X to the fourth minus 10x squared minus 2x plus 4 all over x minus 3. All right. So here we go. X minus 3. That's what we're dividing by. And I'm going to write x to the fourth followed by what? Yeah, very good. 0, x cubed minus 10x squared minus 2x plus 4 there. Okay? Placeholder. Don't forget that. Okay, underline that there. Right? We need that 0x cubed. Alright, so again, same idea here. We want what times x gives us x to the fourth. So what would that be? X cubed, x to the third. Yep, so x to the third times x to the fourth. X to the third times minus 3x cubed. You can see why we need that placeholder in there. Okay, if we didn't have the placeholder in there, we'd be trying to do minus 10x squared minus 3x. You know, we do the negative 10x squared minus 3x cubed, and we'll be like, ooh, how do you combine those? You can't, right? So you need a placeholder in there just to kind of help out the algorithm to make it work. Okay, we'll subtract the quantity, but really make it, you know, add the opposite. So plus a negative and a positive there. Okay, so the x to the fourth cancel, and then 0 plus a 3 is 3x cubed. And then bring down that minus 10x squared. Okay, and what's the next thing we should multiply by here? We need what times x gives us 3x cubed? 3x squared, yep. So 3x cubed, and then minus 9x squared. And again, minus, subtract the quantity. So it becomes plus negative and positive 9x squared there. Those cancel. Negative 10 plus 9, negative 1x squared. Bring down that minus 2x. Notice things lined up, right? So like if you kind of like see the divisions here, I'm making this like really messy now, but like all the x cubed terms line up, all the x to the fourth terms line up, all the x squared terms line up, and then all the, you know, the x terms are going to line up here too. Let's see here, we multiply by a negative x, it looks like, so negative x times negative x, or negative x times positive x is negative x squared, negative x times negative 3, positive 3x, subtract the quantity, so plus positive negative, let's see, those cancel, negative 2 plus negative 3, negative 5x, and then plus 4. Nothing like filling up a whole, or half of a page of your paper, right, with this problem. Unless you negative 5 then, right, is the last thing. So negative 5 times x, negative 5x, negative 5 times negative 3, positive 15, subtract, but really plus positive negative, so those cancel, and then 4 negative 15 is negative 11. Okay, so we have a remainder, right? It doesn't really make sense to start going into decimals here or anything like that, because you really have like decimal polynomials, and you have like decimal coefficients, but not like decimal powers or anything like that. So this we'll say is our remainder. So we'll say remainder negative 11. Okay. We have a remainder of negative 11, which means then that this polynomial here is equal to our answer, you know, the x cubed plus 3x squared minus x minus 5, and then to throw that remainder in, okay, I'm going to say plus negative 11 over the x minus 3. That still has yet to be divided, right? That negative 11 is remaining to be divided. So leave it in there. Why don't I need to put the little x not equal to 3 caveat in here, like I did with the earlier problem? Why don't I need to like exclude the problem? Why don't I have to exclude 3 in this case? Exactly. We still have the same domain restriction here and here, right? The domain restriction still occurs in both situations. If you put a 3 in here, this thing is undefined. If you put a 3 in this will still be undefined, and so the whole thing's undefined there. So they still both have a problem at 3, and so we don't need to worry about that exception, right? All right, one more here, and then we'll move to synthetic division. Okay, and I would give this one to you, but, well, I don't know. If you want to try it, I mean, you can run ahead of me, because I'm pretty slow. Okay, so let's see here. X to the fourth plus 3x squared minus 10x squared. I know it's kind of boring we're doing these x to the fourth, but, you know, the higher powers you go, the more work you have to do. So I'm trying to balance variety with, you know, convenience and time and stuff like that too. So anyway. Here is where the power of long division really shows itself. Okay, here's where the power of long division really shows itself. Okay, because this kind of problem is long division is really the only strategy we have to do something like this, or at least that we currently know and stuff like that. So we're going to divide these two things. All right, and we write it the same way we normally do, right? We're dividing by the x squared plus 4x minus 6, so we'll write that out front, put our little bar there, and we'll do the x to the 4th plus 3x squared minus 10x squared plus 15x minus 10. Again, we check for any placeholders, but there's no need, right? We go from a 4th to a 3rd, if I write it correctly, and that should be a 3rd there too. Yep, sorry, so it's x to the 4th plus 3x cubed minus x squared. So we go from a 4th to a 3rd to a square to a 1 to a constant. And then what we're dividing by is a square to a 1 to a constant, so we're good. We don't have to put any placeholders in either one. And so you do the same thing you did before, okay? What times x squared? Only using that lead coefficient, not really, or lead term, not really worrying about the other two. They'll fall into place here. So we'll just put an x squared in here, right? X squared times x squared will give us x to the 4th, and then you just keep distributing. So x squared times 4x cubed, x squared times 6 minus 6x squared. And again, we subtract the quantity, which again I'm going to change to adding the opposites. Okay, so those cancel. 3 plus negative 4, negative 1, x cubed, negative 10 plus 6, negative 4x squared. We need to bring down that 15x still, but again, we're just bringing down, you notice we're only bringing down one term at a time after we kind of do our subtraction. We're only bringing down one thing at a time here. Okay? Because that gives us those 3 terms that we'll then get from here. So, alright, so we need a negative 1x cubed from an x squared, so negative 1x times that gives us negative 1x cubed, negative 1 times positive 4, negative 4x squared, negative 1 times negative 6, positive 6x. And again, subtract the quantity. So, same change. Am I going too fast?
Yeah.
Sorry. I don't want to bore you guys either, so I wanted to make sure we get through it. But if I'm going too fast, thank you. So all right, I will slow down here. Sorry. I'm like a little machine, I guess. I thought I was slow. I apologize. I'm going too fast. All right, I will stop. And please, yes, please, say something, okay? Say something. Even if you're the only one in the class, okay, I will wait for you, all right? And I will fend off all the judging glances of people that are, saying, "Oh, you're too slow," I will try to at least, but, all right? I apologize for going too fast. So now something interesting happened at the end of this, or not the end, but like where we are right now, in that both the x cubed terms and the x squared terms canceled out. So all that we are left with is 9x. Okay? Now what's our next thing we still need to do here? Bring down the minus 10. Right, we still got to bring down that minus 10. All right? But now we have to ask ourselves, okay, what times x squared is going to give us 9x? And the answer is, we can't really multiply. We could do like 1 over x there, but we're not going to mess with fractions again. We just want like nice kind of terms and stuff. So we're not going to mess with 1 over x, I'll say. So that's our remainder. Okay? Yeah? Oh, what are you going to say, Sean? Sorry.
No.
Okay. Yeah. So this is our remainder. This is our remainder. All right? The 9x minus 10, because there's no, there's no x term or constant we can multiply x squared by to get a 9x. Okay, we can multiply, we put a 9, but it'll be 9x squared there. Right? And so this is our remainder. This is our remainder. Okay, and so we have then the remainder, 9x minus 10.
which means that when you divide these two things, you end up with an answer of x squared minus 1x plus, and then the quantity 9x minus 10 over, and then you still have to divide it by x squared plus 4x minus 6. Okay. So those two things divided give you that. Alright, so questions on any of that long division? Questions on any of that long division? Okay. Alright. So now we get into synthetic division then. We'll look at synthetic division. Alright, which is like sigh of relief. It's a little bit at least. Okay. Synthetic division is a shortcut for dividing polynomials. By binomials. Okay, so this shortcut only works if you're taking a polynomial and dividing it by a binomial, okay, of the form ax plus b. Okay, so synthetic division is a shortcut for dividing polynomials by binomials only. So that means that last problem that we just did using long division, you can't use synthetic division on that problem, okay? So that's why I said that last one was kind of showing the power of long division, because synthetic division won't work there. Okay, it won't work. You can only divide by binomials, and the last thing we divided by was a trinomial, right? 3 terms in it. All right, so let's look at an example here. Okay, and let's just say, you know, we'll say this is simplify. Okay, and we'll simplify the function 6x cubed minus 19x squared plus 16x minus 4 over x minus 2. Okay, surprise! It's the first one that we did, but now we're going to do it in a different way so you can compare answers and stuff. Okay, so synthetic division, right? Something you guys have seen before. And you know, people kind of draw the little box here thing in a different kind of way, but I'm going to put the box in here. All right, so what goes here in this little box, all right, is the solution, or the kind of like the 0 here. So x minus 2, that means the 0 would be positive 2. So it's going to be a 2 that goes in there, right? We're going to put a 2 in there. So we kind of like get this, and that goes like, okay, 0 of x minus 2. Okay, goes in there. The 0 of x minus 2 goes in there. And then all up in here are the coefficients, so of the thing that we're dividing. So 6, negative 19, 16, and negative 4. And so it's obviously important that they're in order from least to greatest. So coefficients in order of, you know, from, I guess I shouldn't say least to greatest, because I would think you, in order of degree, I guess. Okay, so yeah, x cubed, then x squared, then the x, and the negative 4. And of course, you want to include placeholders if necessary. Okay, placeholders if necessary. Then we'll leave a line, and we'll draw a little line right here, because we're going to put numbers down in here, right? So that's all of our setup. And then we finally can start doing the synthetic division. All right, and we start by taking this 6 and dropping it down to right here. And then that 6 we multiply with a 2. Okay. And then we put that value right there, the 12. Okay, and then we add down there. So negative 19 and 12, negative 7. Okay, and then we multiply. Negative 7 times 2, negative 14. So again, the new number here, we repeat the same process. Negative 7 times 2, negative 14, so that gets put in right here. And then we add these two numbers together now. 16, negative 14, 2. Okay, the 2 we multiply up to the 2 there, 4. Negative 4 and 4, 0. Okay, this number right here, that's our remainder. So that means this thing divides evenly, right? We have a remainder of 0. So that's our remainder. And then these numbers right here are the coefficients of the solution, but just reduced by 1 degree, or 1 power. You know, so whereas before our highest power is x cubed, that means our solution is going to be 6x squared, then minus 7x, then plus 2. Okay, and so there it is. Questions on any of that? Alright, let's try another one here. And I'll give you guys one to try. X to the 4th. Minus 10x squared minus 2x plus 4 all over x plus 3. Alright, so we'll draw a little box. And James, what number goes in that little box there?
Negative 3.
Negative 3, very good. It's the 0 of the x plus 3, so it's negative 3. Very good. Alright, thank you, James. And let's see here. Oh, someone who's present. Alyssa, what are our numbers going to be here?
1.
1?
Negative 10.
Oh, careful. We jump from x to the 4th to x squared.
0.
So there you go. Very good. And then continue.
Negative 10.
Uh-huh.
Negative 2.
Yep.
And 4.
Very good. All right. Yes. Okay. So I threw that one in there because this one's missing an x cubed term, so you want to, don't forget those placeholders. Very easy to miss. So can we drop down that 1? And we just do our little arm. So 1 times negative 3 is negative 3. 0 plus negative 3, negative 3. Okay. Negative 3 times negative 3, 9. Negative 10 and 9, negative 1. Negative 1 times negative 3, 3. Negative 2 plus 3, 1. 1 times negative 3, negative 3. 4, negative 3, 1. Now we have a remainder. So, that means we have x cubed minus 3 x squared minus 1 x plus 1 plus, and then 1 over that x plus 3, because again that remainder of 1 means we have, still have to divide that by x plus 3. And so, like that. And there's our simplified version there. Questions on any of that? Alright, so here's one for you to try. Alright. Simplify 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18 over divided by x minus 2. Okay, simplify that. Then divide your answer by x plus 3. Then factor that answer. Okay, neat. Okay. I take all the easy ones and give you guys the hard ones. and I'll work slowly up here on the board, so that way you can kind of catch a mistake early. Because if you make a mistake early, it's going to really mess everything up. So, Question, James. Right, but don't forget, this 1 gets multiplied with 2x, so it makes 2x, and then 3 times x makes 5x when you add them together. Any question? Okay. Does this work right here? Okay. Yeah, that's right. So then after that, affect that final answer. Okay. So, why are we throwing in, after talking about factoring polynomials and factoring quadratics, why are we throwing in this kind of like long division and synthetic division? Well, you can kind of see here, I mean, what did we really do? We took this polynomial, the 2x to the 4th, plus 7x cubed minus 4x squared minus 27x minus 18. We took this polynomial, okay, that we otherwise have no real way to factor, right? I mean, there's no GCF here. Factoring by grouping doesn't really work because there's 5 terms, an odd number of terms there. This is not really like in the form of quadratic, so substitution wouldn't really work. And so to factor something like this, we would be stuck, right? We don't have a tool for it. But using long division and synthetic division, we are able to break it up into factors, right? We know that this is just x minus 2 times x plus 3 times 2x plus 3 times x plus 1. Okay? And so that, numerator there, that polynomial, is equal to x minus 2 times x plus 3 times 2x plus 3 times x plus 1, because those things all evenly divided, are polynomial there on top. All right? But what's the problem? What's the problem with this strategy, though? What's the problem with this strategy? When we use, factoring by grouping or factoring out of GCS and stuff like that, or factoring quadratics, okay, we didn't know what we were going to end up with, right? We didn't know, we just knew we could use those strategies here. But here, we're given stuff, right? We're told what the factors are, right? We're told to divide by x minus 2. We're told to divide by x plus 3. And so, obviously, it's not a very good strategy thing to start. If, we're having to figure, if we need to know ahead of time what already divides it, right? And so, later, tomorrow, we'll look at how we can kind of, come up with a list of possible zeros and things to help us then go through and divide and stuff. All right, so there we go. There's another tool now that we have to help us kind of factor and break down polynomials. All right. So your homework for tonight is page 157 in the book there. Numbers 12 to 45 every third, or multiples of 3 if you want to think of it that way. Okay, every third problem. And then also numbers 60 and 61 as